Okay, so let's just see where we are. To recap, we said we did normal population, simple random sampling, known sigma, small sample size relative to population size. And then x bar plus or minus c star sigma over root n contains the population mean mu for c% of samples. So c star depends on the confidence level c. This is shorthand for the interval x bar minus c star times sigma over root n and x bar plus c star sigma over root n. Terminology going along with this process, the z star sigma over root n, we said over there that ordinarily this thing here would be an estimate, and this thing here we call the margin of error. Okay, so z star sigma over root n is called the margin of error, sometimes called ME. And sigma over root n is called the standard error of the mean because it's the standard deviation of x bar. It's the population standard deviation divided by square root of n. So it's the standard error of the sample mean, actually, but we call it SEM, standard error of the mean. So let's find those two quantities. If sigma is 4.33, n is 100, and c is 99%. The margin of error is z star sigma over root n. For 99%, z star is 2.576. We said sigma is 4.33 and n is 100. And you get 1.12. The standard error of the mean is just sigma over root n with no z attached. So that's 4.33 over the square root of 100. And that's 0.433. So you quite often see in experimental data a column in a table that's called standard error of the mean. It tells you how variable the sample mean is, so it tells you how reliable the sample mean is at predicting mu without actually computing any confidence intervals or anything. You just know that's the standard deviation, that's how much variability there is in x bar. That's nice to know if you're looking at experimental information. Alright, I don't know how many more pages there can be, but there's more.